All right, so now we're back. So as you guys can see here, it took kind of, almost half an hour just to go through all that grid. As you guys can see here, it's kind of different, trying all the different combinations of C, gamma, and of C and gamma mainly, parameters. And we ran through 48 fits, and it just select the best one. And here we're just gonna provide you with the best one. So simply, if you put C of 100 and gamma of 1, that's kind of the best values that we could ever use. All right, let's run this, and again we ran the exact same values again. But the key element here is simply when we use grids, that's kind of our trained model. So when we use the support vector machine on its own, SVC underscore model, that's our trained model. Okay, it's kind of the object that we're trying to apply the method on it and stuff. And then afterward here, when we apply the grid search, our grid is actually our trained model. So what we do here, that we do grid.predict, again, use it, just, treat the grid value exactly the same as the SVC underscore model, exact same fashion. So grid.predict, that will give us the grid predictions. We're gonna do, again, confusion matrix Y test with grid prediction. We're gonna give us CM, SNS, or Seaborn heat map. And then we're gonna report the, print the classification report. As you guys can see here, we actually achieved 0.99% or 99% precision as compared to 95, which is great. And here the number of samples as well, we misclassified 101, 143. Here we misclassified 34 and 31, which is, like a huge improvement when it comes to classification. All right. Okay, that's great. So now we know how can we train a model using support vector machine classifier. We now know how to even make it better and better. Okay, using the grid search. Now let's actually to the fun part, and let's take a look at how can we take an actual image, that the model hasn't seen before, and actually try to predict or detect at least the location of vehicles. All right, so let's load an image. That's again, it's kind of a test image desired. All right, so let's run it. So as you guys can see here, this is kind of the image, and our objective is to try to detect, for example, these vehicles. Okay, obviously you have done that before, like we've done template matching, but unfortunately this technique is not very robust. We can try to detect, for example, corners. We have done that before. We can detect using like fast. Here we use hog features. We trained the model to classify cars in general, and now to the actual test. Let's test it with an image of an actual true road, and we see how can we detect this. All right, okay. So first step, we're going to define, the H start and H stop. That's kind of the region of interest. I don't need to look for cars, for example, here in the sky or here in the hood. So what I'm going to do here, we're going to define these values. Here I'm going to define, pretty much the values for the hog feature. We're going to use, again, pixels 16. The cell, we're going to be 16 and 16 by 16. They're going to use hog orientations 11. Cells in block, we're going to be 2, and cells in step, we're going to be 3. And here, what I'm going to do here is simply we're going to crop the image or the region of interest out of this image and plot it. Let's take a look. So that's pretty much my image that I'm interested in. Okay. All right. One key element to consider is that we might need to actually resize our image. Okay, in the same fashion as pyramiding, to try to fit, because our image was 64. The dimensions are around 64 by 64. If you guys recall, 64 by 64, the image. So what we need to do here is that we need to maybe, again, here in this model, because it's very simple, we're just going to use just one size, one resizing factor. But it's, in general, if you want to make it like a way more advanced way of doing it, you can actually try to use different values. You can try to make it smaller, you can try to make it bigger, and that's how you can look for elements or objects within the image. But here we're just going to use one size, just going to rescale it to use a resizing factor of 2. And then what we're going to do here is just going to apply the resizing factor to simply obtain the L value, W value, and then here we're going to use the L value and W value for the resizing, just to resize the image, simply to cut it in half or to magnify it in a way. Let's run it, and let's run it one more time. And that's pretty much it. So if you guys can see here, we actually cut it into half pretty much. The image is pretty much the same. However, if you guys can see here, it's, let's say, from 0 to almost to 100. It becomes from 0 to 100. Here it was stopping at around 1200. It becomes 0 to 600. So we just pretty much cut the image into half. All right. Okay. The next step is we're gonna take that image, which is, you know, kind of the region of interest. We're gonna apply hog features to all image. And that's the whole idea. We're just gonna do it one time. And instead of actually dividing and extracting parts of it, we're just gonna get hog feature for the whole image. And then afterwards, we're gonna scan the entire image to try to find simply the match, pretty much. Okay, let's run it. And that will obtain just the hog feature. So now I have masked region, hog feature all, which is simply the entire feature for the entire region of interest. And now to the fun part. Now actually when I take this, slice it into different sections and predict to run it to the train model to try to tell us, do you recognize any of these features? Do you see there might be a car in any of these features or not? And that's pretty much the whole idea. Okay, all right. So in this section, I'm not gonna go through all the details of this. This is pretty much in a nutshell. What I'm gonna do here is simply try to scan through the image. So you have your hog features. Every time you're gonna go, you're gonna extract a piece and simply run the predictor in a nutshell. Running the predictor, that's the only part I wanted to cover, which is simply here. What I'm gonna do here is I'm gonna do SVC model dot predict, and every time I'm gonna got hog feature sample, which is kind of the extract portion of the image, all right? I have two options, either use the basic SVC model or actually my optimized model, which is grid.predict. Actually, the results here are not that much of a difference, okay? But that's where you can actually try, you know, for example, testing two different models. One that's, you know, a little bit more optimized, which is grid, and the other one, which is the basic one. All right, let's run it. Okay, looks good. And simply put, what I'm gonna do here, the only objective out of this section is to get rectangles found, which is simply a list of all rectangles, or when I say rectangle, that means, okay, that means a car has been detected. That means a flag that has been set to 1. The whole idea is, if the test prediction is 1, that means if I run the model and the model predicted that, okay, this feature matches actually one of the hog features that I know beforehand, the trained model knows beforehand, that means we're gonna raise a flag of 1. That means test predictions is equals to 1. If the test prediction equal 1, I was just gonna get the dimensions and extract the rectangles in a nutshell, in a very simple form. Let's actually view the rectangles found, and that's pretty much all the rectangles found. And let's plot this. And that's it. Now to the fun part. Actually, you know, the feature, the support vector machine classifier was able, the trained one has been able to classify that these two portions are actually vehicles in here, which is pretty exciting, pretty interesting. That means now we took basically the feature or the object detection to the next level. Now we can actually run this, for example, into video stream to actually detect, for example, objects, okay? Now we can take this again to the next level, and instead of, you know, drawing this in a way, we can actually try to change the size here using pyramiding to actually try to detect different features at different depths of the image, and you can do like wonders with it. It's really impressive. But here again, I'm not gonna dig into like a lot more detailed kind of, for example, video stream or all of these like advanced topics. Here I'm just gonna give you a whole idea of how can we extract features using hog features, train a classifier using support vector machines, how can we optimize the classifier to optimize gamma and C parameters to obtain a better fit, and then afterwards, how can we use this to predict or to detect object in an actual image. All right, and that's pretty much all what I have for this section. I hope you guys enjoyed it, and see you in the next section.